Okay, so this is problem 12 from chapter 5. So for problems 12 through 16, you assume that you manage a risky portfolio with an expected return of 17%, standard deviation of 27%, T-bill rate is 7%, which happens to be a risk-free rate. So, and then your client chooses to invest 70% of the portfolio in your fund and then 30% in the T-bill. So I've recreated all that in a table over here. So we got the weights and we got the expected returns and standard deviation. Since the T-bill is risk-free, that standard deviation is 0. So first part A is the expected return and standard deviation of your client's portfolio. So that is just, we take the 70%, we multiply it by the 17% and then the 30% times the 7% comes out to 14%. So just to type the formula, so that'd be 0.7 times 17 plus 0.3 times 7. So now for the standard deviation, that's actually even easier because we only have one risky asset. It's 70% times the standard deviation. So at 18.9%. So equals 0.7 times 27. There we go. So next part B, suppose your risky portfolio includes the following investments given proportions. What are the investment proportion of each stock in your client's overall portfolio, including the position in T-bills? So we already know that T-bills are 30%, but we've got 27%, 33%, and 40% that comprise the risky portfolio. So in order to calculate the weights, we take the 70% and we multiply it by each of the respective weights. So I'm going to do an absolute function F4 so I'm going to pull it down, and then so I'm going to pull this down to C, and then I know that the T-bill is 30%, so now I've got 100%. So my weight in stock A is 18.9%. My weight in stock B is 23.1%. My weight in stock C is 28%. And my weight in the T-bill is 30%, which is what we already knew. And it all adds up to 100%, which it always has to. So next we have the Sharpe ratio. So pasted the formula for the Sharpe ratio in. So Sharpe ratio is the expected return on the portfolio minus the risk-free rate divided by the standard deviation. And so we'll show you something after I do the calculation. So expected return on the portfolio is 14 minus the risk-free rate, which is 7%, the T-bill rate, divided by the portfolio standard deviation. Whoops, so I need to make that, I'll do that, make a comma. So it's or 0.37 or 0.37, however you want to say it. So it's that's the slope of the capital allocation line, which is the next part of the question. But the risky portfolio is also on the capital allocation line. We'll show that. So expected return minus the risk-free rate divided by the standard deviation. It's going to be identical. So it's the Sharpe ratio is the slope of the capital allocation line. So the final part of the question is to draw the capital allocation line. I didn't draw it, but I actually copied it in here. So on the y-axis, we have the expected return, and then we have the standard deviation on the x-axis. So we have the T-bill rate, which has a standard deviation of 0. We have the expected return on our portfolio, which has a standard deviation of 18.9. And then we have the expected return on the risky portfolio, and it has a standard deviation of 27. So we draw a line through those points, and that is the capital allocation line. So with a slope of 0.3704, we calculated it as 0.37, but that's just rounding. So that's all there is to problem 12 from chapter 5.